Okay guys, welcome back to my channel. Today we'll be talking about the physics post-UTME examination questions you should be expecting in your exam for the science students for life science, engineering, and your physical sciences exam, which starts tomorrow. So please, these questions are very sacrosanct, and you should make sure you watch this video to the end before you enter into your post-UTME or starting tomorrow. God bless you. Number one says, as shown on the screen, a cell of internal resistance 1 ohms supplies current to an external resistor 3 ohms. The efficiency of the cell is dash. Now quickly recall, for efficiency of a cell, the formula goes like this. Okay, capital R divided by capital R plus small r times 100 over 1, where capital R talks about the external resistance and small r is the internal resistance. From the question given to us, we're going to say efficiency should become a capital R is 3 over, we have 3 plus 1, then times 100, and this should give you 3 over 4 times 100, and that should be around 75% as the answer to that question. Number 2 says, if the fraction of the atom of a radioactive material left after 120 years is 1 over 64, what is the half-life of the material? Quickly recall, from radioactivity, the fraction left is equal to 1 over 2 to the power of n, where n is the total time divided by the half-life. So quickly, we can solve this from this formula on the board. So the fraction was 1 over 64, and this is equal to 1 over 2 to the power of, now the total time was 120, and then we're asked to find the half-life. Now recall, 64 also means 2 to the power of 6. So we can say 2 to the power of 6 over here, and then we can say 1 over 2 all to the power of 6 equals 1 over 2 all to the power of 120 over the half-life. Now quickly, if you observe the board, the bases are the same. You can strike out the base and then equate the powers. So we have 6 equals 120 divided by their half-life. Now you can cross multiply. The half-life should be 120 divided by 6, and that should be 20 as the answer to that question. Number 3 says, the main reason for making the cover of a vacuum flask airtight is to prevent heat loss by dash. Now quickly recall, for your vacuum flask, we have 3 things we use to prevent heat loss. The first is the cork, okay, the cork, and then we also have the sealed body, and then we have the vacuum in the bottle. So we have three compartments we apply in preventing heat loss: the cork, the sealed body, and the vacuum. Now quickly, the cork prevents heat loss by convection and evaporation. Okay, the cork prevents heat loss by convection and evaporation, while the sealed walls prevent heat loss by radiation, and then the vacuum prevents by convection and conduction. Okay, but mainly by convection. So the answer to that question should be convection. Number 4 says, a radio is operated by 8 cells, each of EMF 2 volts, arranged in series. If 2 of the cells are arranged wrongly, find the net EMF. I'll give you a formula to apply for cases like this. Now quickly, the net EMF, okay, the net, EMF is equal to capital N minus 2x all into E. The net EMF equals to capital N minus 2x all into what now? E. Where your capital N is the total number of cells given, and then the X is the amount of cells arranged wrongly. So we're going to see from this question, total cells were 8. So we have 8 minus 2 times, just 2 were arranged wrongly, and all times 2 volts. So this should give you 8 minus 4 into 2. That is 4 times 2, which should also be 8 volts as your answer. Number 5, if the force and the velocity on a system are each reduced simultaneously by half, the power of the system is dash. Quickly recall that power is equal to force times velocity. Okay, so basically the force was reduced by half. So we need the new force is F over 2, and the new velocity is also F over 2. So speed 1 is speed 2. Okay, now if you compare the power 2 is actually 1 over 4 of the power 1, because this guys will give you FV over 4, and FV is power 1, so 1 over 4. So the answer should be reduced to a quarter, option B. Number 6 is total internal reflection occurs when light moves from dash. And quickly, for you to easily understand TIRO, just remember water and air. Okay, so when light travels from water, okay, it's incidence on the surface, and then it's going to refract because you have two different medium. Okay, so its incidence from the water to the water surface is going to refract in air. Okay, going to refract in air, so it's basically going away. Okay, so we have something like this. So when you have a wave moving from a dense medium to a less dense medium, you're going to basically have TIRO as you are moving in that medium. I'm not going to explain properly. Now, if this your incident strikes this boundary, the angle called here is angle of incidence. Now, when your angle of incidence is greater than critical angle, when this your I is greater than critical angle, this refracted ray is going to now refract into the water back. So this is now looking like reflection. So total internal reflection occurs when your incidence angle is greater than the critical angle. And the critical angle is the angle of incidence when the angle of refraction is at 90 degrees. So the answer to that question should be from a dense medium to a less dense medium, option A. Number 7 says the velocity ratio of a machine is 5. So VR equals to 5 from the question, and the efficiency of the same machine is 75%. What effort would be needed to lift a load of 150 Newton? Now recall, efficiency of the machine is mechanical advantage over velocity ratio times 100 over 1, and mechanical advantage equals to load over effort. So we're going to say we have 75 here over 100 because the MA is load. The load is 150 over the effort is unknown. The velocity ratio was given as 5, and then we have this to simplify. So quickly, we can say 5 here, 1. 5 into 15 is 3. We have 30 over there. We're going to cross multiply. Basically, it's going to have 75E, okay, equals to 300. And then divide both sides by 75. Okay, so the effort should be, so we should go in about 4 times. So the effort should be 4 Newton as the answer. Okay, sorry about that. I have an error here. 30 times 100 gives you 3,000, not 300. That's an error from my part, sorry. So if you divide, you're going to get 40 as the effort. 40 Newton, that's option C as the correct answer. Number 8 says, in a series RLC circuit at resonance, the voltages across the resistor and the inductor, so the voltage across the resistor and the inductor were given as 30 volts and 40 volts respectively. What is the voltage across the capacitor? Now take note, at resonance, these key things are very important. At resonance, your VL is always equal to VC, your XL must be equal to XC, your impedance must be equal to R, your total V must be equal to VR, and then your phase angle must be equal to 0, and then your resonance frequency is 1 over 2 pi square root of LC. These conditions are necessary for resonance to occur in an AC circuit. So quickly, the answer should be VL and VC are the same. So here should also be what? Should be 40 volts as your answer. Number 9 says, when a ship sails from salt water into fresh water, the fraction of its volume above the surface will dash. Now quickly, I'm going to give you a diagram to understand this. We have water here. Let's demarcate the water. So here is salt water and here's fresh water. Now, salt water has more density than fresh water. So in the salt water, the ship should have more fraction outside the water. When it gets to fresh, it should have more fraction inside the water because it's going to sink a bit. Okay, so basically the fraction of volume above, see, the volume above here is higher than the one here, so it's reducing. So the answer should be option B, decrease as it goes to fresh water. Number 10, a semiconductor diode is used in rectifying alternating current into direct current, mainly because it dash. Now, quickly, we use what we call a diode, which are rectifiers, because they allow current to flow in only one direction. So the answer to that question is option D. Number 11, gamma rays are produced when, that's a question. So quickly, where do you get gamma rays from? Under topical radioactivity, and that's a nuclear physics question. So basically, it's produced from the nucleus of an atom. So the only option here that has that looks like option B, when energy changes occurs within the nucleus of atoms. Option B is correct. Number 12, the core of an efficient transformer should consist of laminated pieces of metal in order to dash. Now, when you laminate, you are going to reduce the heat produced, okay, by reducing eddy current. So the answer should be option D, reduce the heat produced by reducing eddy current. Number 13 says, in Fleming's right hand rule, the thumb, the forefinger, and the middle finger, if held mutually at right angles, represent dash. Now, quickly recall, for Fleming's right hand rule, we hold the thumb, the first finger, and the second finger at right angles to each other. Now, quickly, the thumb represents the motion or the force, the first finger represents the field, and the second represent the current. So remember, thumb, M for motion, thumb, so motion, first finger, F for field. So first finger is field, and the second, C for current. So the answer should be the motion, the field, and the induced current. That should be option A. Number 14, at what frequency would a 10 Henry inductor have a reactance of 2000 ohms? Now recall, the inductive reactance is 2 pi FL. Now they give you the reactance as 2000 ohms. We're going to say equals to 2 pi times the frequency we are looking for, and the inductor or inductance was 10. Quickly, 10 takes out the 0, and 2 here takes out the 2. So F should be 100 over pi hertz as your answer, option C. Number 15 says a 3000 watt electric cooker is to be used on a 200 volt mains circuit. Which of the fuses below can be used safely with the cooker? Quickly, let's find the current. Okay, recall P equals to IV, so I should be equal to P over V. Now the power was 3000 and the volt is 200. So we're going to cancel out these values, and then this should be 15 amperes. But now remember, it's a fuse, so you should use a rating that is slightly above this value. So the only correct option then should be option D, 20 ampere, because the rest amperes, or the rest current rather, would blow when you use them. So the answer is option D. Number 16, an astronomical telescope is said to be in normal adjustment when dash. The answer is when the final image is at infinity, option D. Number 17, four cells, each of EMF 1.5 volts and internal resistance 4 ohms are arranged in parallel. What is the effective EMF and internal resistance of the combination? Now, quickly, when you are in parallel, your effective EMF remains just one of the EMF of the cell. So that should be 1.5 volts. And then, since they're in parallel, you're going to solve for the total resistance by doing your 1 over value. But I'm going to put my shortcut because they have equal value. Just pick one value over how many appears. So the one value was 4, and then we'll say over 4. Since there are 4, this should be 1 ohm. So the answer should be 1.5 volts and 1 ohms, option D. Number 18, the velocity of light in air and glass. So velocity of light in air, 3 times 10 raised power 8 meters per second. Velocity of light in glass, 2 times 10 raised power 8 meters per second respectively. The angle of refraction is 30 degrees. Find the sine of the angle of incidence. Now recall, okay, that your refractive index equals to sine I over sine arrow, okay, or velocity of light in air velocity of light in the medium or in glass. Okay, so quickly we're going to use this to solve. So sine I is what we're looking for. Sine r, that's sine 30, equals velocity in air 3 times 10 raised to power 8, and in glass 2 times 10 raised to power 8. This takes out this, okay, and this here becomes 1.5. So we have sine I becomes 1.5 times sine 30, and sine 30 is 0.5. So this should be 0.75 for sine I. Number 19, the inside portion of part of a hollow metal sphere of diameter 20 cm is polished. The portion will therefore form a dash. Now, quickly recall, now this is a hollow metal sphere, so it's not a glass. So let's imagine a sphere, hollow. Now the inside portion is polished, not coated. So this internal portion is called polished, so it forms a glass, forms like a mirror. So it is the internal part of this shape that now gives you your mirror. And how do you know concave or convex? For concave, okay, it is the curved part that is your mirror, the inside part. So this looks like a concave mirror. Since the diameter was 20 cm, the radius will be 10, and then the focal length will be 5. So the answer should be a concave mirror with focal length 5 cm, option A. Number 20, a man stands 4 meters in front of a plane mirror. If the mirror is moved 1 meter towards the man, the distance between him and his new image is dash. Now, if you recall, for plane mirrors, okay, the image distance is always equal to the object distance. So initially, the man was here, okay, and from the man to the mirror was 4 meters, meaning from the mirror to his image would also be 4 meters. Now the mirror was brought 1 meter towards the man. So the mirror is now somewhere around here. So from the mirror now to the man is 3 meters, meaning his new image will also come closer, making 3 meters to the mirror as well. Now the distance between his new image and him is now 3 plus 3, which gives you 6 meters as the correct option, option C. Number 21, the lowest note emitted by a stretched string has a frequency of 40 Hz. That's the fundamental frequency, 40 Hz. Now we're told how many overtones are there between 40 and 180. Now quickly remember, for stretched strings, the first overtone is 2 times the F naught. So 2 times 40 will give you 80. The second overtone is 3 times the fundamental, that should be 120, and the third should be 4 times fundamental, and that's 160. Now check, these values are in this range from 4 to 180. If you try the fourth overtone, that should be 5 times this guy, and that should give you 200, which is way above what they gave you. So we have only 3 overtones between 40 to 180. That's option B as the answer. So number 22 says, calculate the mass of ice that would melt when 2 kg of copper is quickly transferred from boiling water to a block of ice without heat loss. They give you the value for the SHC and latent heat. Now, when you are mixing mass of ice and copper that is from boiling water, remember, we're going to say the heat given off by the hot body, okay, heat given by hot body equals the heat received by cold body. So for the hot body, we have MC, change in temperature. For the cold, which is ice, we have just ML because it's a latent heat. Okay, so now the mass of the copper is the hot body here. So copper was 2 kg and the C of the copper was 400. Now the temperature change. Now from boiling water to ice, that's 100, because boiling water is 100, ice is 0. So we have only the change here. We're asked to find the mass of the ice, and the latent was given as 3.3 times 10 to the power 5. Now, if we solve for M from this expression, we're going to get, I think, 8 over, let's check that out, okay? So we have 2 times 400 times 100, all divided by 3.3 times 10 to the power 5. Okay, and that should give you 8 over 33 kilograms as the answer to that question. Number 23 says the equation of a wave traveling along the positive x-axis is given by this equation, and then you're asked to find the angular frequency. Now recall, y actually is equal to a sine omega t plus or minus kx. So your angular frequency, that's your omega, is a value standing in front of t, and from the expression given to you on the board, That R value is 500. So our angular frequency should be 500 rads per second as the answer. And that number 24, a piece of substance of specific capacity 450 falls through a vertical distance of 20 meters from rest. Calculate the rise in temperature. Now, quickly, rise in temperature when you are converting potential to heat. I call it Gamma over C. That's GH over C. So G is 10, H is the height, which was given as 20, and the C in this case is 450. So we have 200 over 450, and that should be around 0, 5 year 4, 5 years should be around 9. That should be 4 over 9 degrees Celsius as the answer. 25. The temperature gradient across a copper rod of thickness 0.02 meters maintained at two temperature junctions 20 degrees Celsius and 80 is dash. Now remember, temperature gradient is actually change in temperature over length. So the change here should be 80 minus 20, and the length here is 0.02. So this should be 60 over 0.02. So let's see what this should give us. Is 60 divided by, this is 2 over 100. 100 goes up, that is 6,000 over 2, and that should give you 3,000, or 3 times 10 raised to power 3 Kelvin per meter. Option B. Number 26 says when temperature of a liquid increases, its surface tension dash. Now remember, when you increase the temperature of a liquid, you are actually decreasing the surface tension. So the answer is option A, decreases. Number 27, a solid weighs 10 Newton in air, 6 Newton when fully immersed in water, 7 Newton when fully immersed in a liquid X. Find the RD of the, let's find the rate density. Recall, this is equals to upthrust in liquid over upthrust in water. So that don't with liquid here, fluid. Upthrust in liquid over upthrust in water. Now upthrust in liquid is weight in air minus weight in liquid, while for water is weight in air minus weight in water. So the weight in air given was 10. The weight in the liquid, that's X, was given as 7. Weight in air again 10, and liquid is 6. So we're going to have 3 divided by 4, option C. Number 28, a car of mass 800 kilograms attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is dash. Recall, power is actually energy over time. Since it's a moving car, we're going to use kinetic energy half mv squared over time. So we're going to say half the mass of the car was 800, the speed is 25 squared, all divided by 20. When you solve this, you should get 1.25 times 10 raised to power 4 watts as the power in that engine. Number 29 says a lead bullet of mass 0.05 kg fell with a velocity of 200 meters per second into a lead block of mass 0.95 kg. Given that the lead block can move freely, find the final kinetic energy. Now quickly recall, for momentum, m1u1 plus m2u2 equals to m1 plus m2 into v for inelastic collision. For this question is actually inelastic. The bullet enters the wood and stays there. Okay, so mass 1 was 0.05, velocity 1 was 200. Now mass 2 was 0.95, velocity 2 was 0 at rest, and then mass 1 plus mass 2, that should give you 1 times v. Now let's solve for this. So this should be around 10, so v should be 10. Now if v, okay, yeah, if v is 10, the final kinetic energy is coming from the final part, so half m1 plus m2 into v squared. That should be half m1 and m2 is 1, and then v is 10, so 10 squared is 100. So 100 over 2 should give you 50 joules as your answer, option A. Number 30, the inner diameter of a test tube can be measured accurately using a dash, option A. I'm not waste time. Okay, now because we are asked to find for the inner diameter, now micrometer screw gauge measures very small diameters, okay, but it's only for external. So the only option here you should use is the guy that has to do with the vernier caliper, because it measures both inner and external. So option D should be the answer to that question.